My presentation is Buffer or Suffer and the gross pains of continuous delivery pipelines and what you can do about it. Presentation consists of two parts. First part is mainly to introduce you in the terms, and the previous presenter did it really well, but I still like to go through those slides because I would like to get a few points across because I will gonna refer to them later on. But before we start, about myself, my name is Andrei. Don't try to pronounce my last name. Andrei is just fine. I'm a long-time continuous delivery practitioner, worked for multiple companies, currently working for Praqma as impossibility remediation specialist. And in two words, it's basically I'm telling people, yes, you can do it. And they say, no, we don't. And I say, you just don't know how to do it today, and we're gonna figure it out. So there are no impossible things. We are in software business. You can do whatever you like. The thing is, you might don't know yet how to do it. And this is what people call impossible. But, well, believe me, everything is possible. And let's move on. So this is how we usually explain continuous delivery storyline to people. And it consists of multiple parts. One is, and the cornerstone is agile task management, very important. The second part is TDD, then you have continuous integration and continuous delivery. Let's go through the pieces here. So agile task management, why it have to be there? Because you're gonna do continuous integration. In order to integrate continuously, you need to have something to integrate, which means that you have to take your software project, slice it into pieces, so developers have something to work on every day, right? The task. And those tasks they're about to integrate continuously. Then TDD is super important. Why? Because you want to deliver not only source code changes, you want also to deliver the changes to the test cases. There is no way that your developers or that your test engineers will catch up with your developers if you deliver changes to source code and test cases separately. It just doesn't work this way. Continuous integration is super important because then through continuous integration, you secure that you have something to test. And I would like to go a little bit deeper in here. Initially, continuous integration was mentioned in the XP book, XP programming, in the end of 90s. But it became popular after the article by Martin Fowler. And he outlined in his article those practices that you need to implement so you can say that you do continuous integration. It's kind of self-explaining itself, and the one thing that I should point out here is maintain a single source repository. It's not that strange thing that Facebook and Google doing with a huge repository where they have all their source code. No, it's about maintaining your version control dependencies. So for instance, if you include certain libraries in your build process, then you need to make sure that it's not the latest version of the library you are getting in. You need to specify the version of the library. And that's important. And that library might be on a file storage. It might be in Artifactory. The important point here is that you need to version control your dependencies, and they have to be specified in your build recipe. And the rest is everyone commits to the main line every day, kind of understandable. Everyone commit should build on the integration machine, understandable, because through this you solve the problem and works on my machine, but it should work on the integration machine instead. Then you have to automate your tests, and you have to automate your build, obviously. The interesting point here, Fowler assumes that you can have a broken build on your main line. And that was a notion of 2000s when people were doing daily builds. So if you do a daily build, obviously you will have a red build. And the reason for that is that you're bundling multiple changes together. And then you just build it nightly, and then in the morning people have to go in and figure out what the hell actually happened. Another thing that you can do is to run something called Pretested Integration. In most cases, people implement that through the build of pull requests. We wrote the plugin for Jenkins that can help you with automation, and also wrote the article. And just to give you a summary of what continuous integration is, in my opinion. Continuous integration is a set of practices aimed to reduce time, cost, and risk of securing mainline integrity. Basically, making sure that you have your main branch buildable and testable. And that's hugely important. Like back in the companies where I worked as a coach for continuous delivery teams or tools teams, we had a daily build. And we actually have a few people in the room with whom I worked on that. And daily build was always broken. It was weeks when we didn't have anything to test on, since we couldn't really put the source code together to have a test package. And then we went from clear case to Git. And that time we've been using Gerrit. And that's changed a lot of us for us, because then every commit that was supposed to come to the master branch were pre-tested. We would build it before we merge it to the master branch. We would run unit tests, we would run static analysis, we will look for the memory leaks, depending on the project maturity. But that's a general idea. It means that you're getting access to all those benefits of continuous integration. This slide is mostly for me because I keep forgetting some, but the general idea that you have no red builds, system is always testable, and you're getting the fast feedback to developer. You're also extending responsibility of developer, which is very important. Back in clear case times, people would check in and they're done. That's their delivery process. But now they have to take additional step to get their source code integrated into the main line, because you have a gating activity that would not allow the change that would break the build or break unit test to go in, which means that now you have much less effort necessary to start new development. You don't have to go and clean up broken unit tests. The build will work. Continuous delivery. It's obviously built on top of continuous integration. So continuous delivery is a set of practices aimed to reduce cost, time, and risk of producing release candidates. So there is a difference between continuous delivery and continuous deployments. In continuous delivery, you obviously want to produce release candidates and then leave decision for deployment for your management, so they can release the new software when there is a business opportunity for that. If your business model doesn't allow you to take advantage of continuous deployments, then you probably shouldn't. Or you have to change your business model first and then take advantage of continuous deployment. So there are certain benefits associated with continuous delivery, and you heard a lot about them today, so I won't stop that long on this one. I think one thing that requires clarification is reduced amount of tiers. You might think, why? Because when you run the change through continuous delivery pipeline, developer will get feedback within hour, maybe 2, 3, comparing to when you do daily tests, daily builds. Then his change would be bundled with other people's changes. And then you will need to have people with domain knowledge to go in and figure out what actually got it broken and write a trouble report, because they have no idea what change exactly caused that. But in continuous delivery, you're trying to give feedback on every change, which means that you will be able to automatically identify who broke the thing. But we will speak about that later on. Well, then you have your manager asking like, well, what if we just don't do it? Then you're exposing yourself to things like that. So think about it. There was multiple quite serious security holes announced lately. What is your strategy to protect your customers? I mean, when you have your hardware device with your software, you give it to your customers, and then there is a security hole. So if you're a medical company, for instance, then it might be health of the patients, which is in danger, right? If you're a telecom company, then someone can be listening to the people using that. Think about that. How are you about to protect your customer and the users of the customer from those things if you have no ability to update your software? That's the question of the day. That's why you have to think about how to update your business model and how to work together with your customers to get them those software updates. You have to develop that capability, and that's architectural issues. One thing that I want to show, and I hope it works, is a SpaceX. They launched in 2012 the first flight of the Dragon capsule. The company is so broke that if they do not connect to International Space Station, they're out of the business.
5, 4.
So if
3,
this thing doesn't work,
1.
they're out of the business.
Stage 1. Have liftoff of the Falcon 9. Falcon 9 is clear the tower. Starting pitch kick. You have the power systems are nominal.
Detector.
Dragon solar array deployment. Solar has deployed.
They're initiating the capture of the Dragon. Standing by. Capture is confirmed.
A Houston station, looks like we got us a Dragon by the tail.
That was a huge moment for the company. But if you read the biography of Elon Musk, you can read this. So it wasn't that shiny as they show in the video. I really like this moment. So basically, all workers were in the factory. It takes 3 days for the capsule to get to the International Space Station. So what they're saying is, so they figured out that they didn't really account for the sun radiation, and they had a laser device that was supposed to calculate the distance to the International Space Station. And Dragon capsule was about to miss International Space Station because of that mistake. They couldn't adjust and they couldn't steer it well, just because of that software mistake. And the most impressive thing is that, yeah, they decided to upload some new software to the Dragon. Think about that. They are doing continuous delivery to the space capsule, and and then no one can tell me that you cannot do continuous delivery for embedded. I'm not buying that. Here you have people delivering software updates to the space capsule, flying in the space actually. And only because of that, they made it, and that saved the company. This is the capability that you, as an engineer, can bring to the business. So continuous delivery is competitive advantage. Now we're about to move to the second part of presentation, where we're going to speak about how do we scale the whole thing. And obviously the pipeline works in a way that you have the tasks. Well, we have Atlassian as a sponsor, so let's say you have the tasks in Jira, right? So then you have a developer who pick it in Jira, and then he will hack or she will hack on the laptop, and then developer consider himself done or herself done. But that's not how it works in Agile. In Agile, you have to be done. And the way to get the second done is to have your product owner to agree with you that you are done. And the way to get that implemented is either provide the developer a checklist saying that you have to run the test, you have to do the build, you have to update documentation, or you automate the whole thing. And this is what continuous delivery pipeline is all about. It's about automation of your definition of done for developer. So then he would push his changes to a version control system, well, let's say Bitbucket, like just for no reason, or GitHub Enterprise, I don't know, whatever you like. And then we can run integration steps, and you can use Jenkins, Go CD, any system works. And you run the build, but it could be much more than that. And if the integration criteria is passing, then change will be merged to the main line. If not, it will be sent back to developer. So this is the huge difference between daily build. You test every change separately. And you know if it doesn't work, then you just do not accept it. And then you can run much more. And again, here it's very important that you think about that you don't fall to the same pattern. You don't test a bunch of changes together. It's very important to try to run every change through the continuous delivery pipeline, because then if something breaks in functional test, your system can automatically send a message to developer saying, you know, you broke something. You have his mail address in a Git commit ID, right? So I really like this quote. So it's not that hard, really, to implement continuous delivery pipeline. It's basically writing a set of scripts, but then keeping that running green and fast. That's the challenge. And there are a number of problems associated with that. So let's go through them one by one. First of all, as I already said, you want to run a continuous delivery pipeline on every change to make sure that you don't bundle things together and you don't need to have a human intervention to figure out who the hell broke the thing. If you run one change after another, then you're fine. Machine can do it for you. Maybe in 5 years, computers will be even smarter, and then we can run changes together and computers will just figure it out somehow. But at the current state of technology, this is how it is. Which means that you really need to keep your continuous delivery machinery oiled and running well. Because if it starts to fail, just because someone plugged out the cable or your Jenkins is misbehaving, you are about to lose trust from developers. And that's the most scary part, or the most scary state that you can get yourself into. If your developers stop to trust in continuous integration, if they stop to trust in the continuous delivery, if they think it's just a waste of time, you are in a big trouble. I've been in the situation where the team completely disbelieved and they just start to push on master. They said, those tests, it doesn't make any sense. They never work. Your Jenkins thing is crap. It never works. And just to make things worse, they also enabled force push on masters. Oh, that was a hell of a job to fix it and get their trust back. But that was more a pedagogical issue, and you don't really want to get there. So in order not to get there, you need to have your tools team, operations team, whoever runs the tool suite responsible for continuous delivery pipeline, actually taking care of that. And by that, I mean measuring. That's the only way you can get yourself out of the trouble. Because people usually don't really like to work in those teams. Working in those teams means that you have to do firefighting all the day long. And that's why they don't like it. Why do they do firefighting? Because something is always broken. And managers screaming on them. So the only way you can get yourself out of that state is every week go through the breaking builds or broken tests and identify the reason for this build or test being read for every test and build, and then classify them. Basically, then you will have a top 3 lists, top 3 issues that causing the most disturbances to you, and you have to work on those top 3, not what your manager telling you. Because then, as you solve those 3, you will have much less disturbances, and you will save a little bit of time for your team to start working on some proactive measures. And within a month or 2, you will get yourself out of there, so you might need to have one person to respond to immediate needs, and the rest of the team working on some creative tasks instead of doing firefighting. That's very important, and for some reason, almost no one is doing that. How do you think what this is all about? That's how we work with the legacy systems. And it's all about technical depth. I'm going to speak a lot about that, so I don't want to go into details, but it is increasingly important. I mean, when you have your continuous delivery pipeline, you should ask yourself, all right, I have 1,000 of test suites that I have to run. Do I have to run all of them? And I have those 5 that never fail. What is the value of running those? You have some dead source code in there, maybe. Do you still have to build it? And it's very rare when team actually goes back and start to delete code. They add code again and again and again every day, but they don't delete. So their build becoming bigger and bigger. Your test suits becoming bigger and bigger. And you need to think about that from the perspective of the technical depth. That's your technical depth that you need to pay one day. Or you might have your project manager running to you saying that you have to release on a Friday evening, when no one is really can take care of the release and no one is really waiting for that, but for some freaking reason you have to release it on Friday evening. And not everything is ready. You don't have your static analysis ready. You still have some lint warnings, or you might have a memory leak. And he said, yeah, it's fine. Yeah, we just get it out. It's fine. What you have to say is, it's fine, we get it out, but then we create the tasks in our backlog system, making sure that we have a task that will allow us to get back, plan it, and address this issue. Otherwise, they're just getting away with this. You have to visualize the depth so people start to understand. When you take a shortcut, you're actually adding things to the backlog. And that's the graph that basically shows that as more depth you have, the harder it's implement the new functionality. The same with continuous delivery pipeline. You have to treat your automation scripts, your test scripts as a code. The same goes there. Usually, for some reason, people treat test code as like a second type cheats, and yeah, fine, we can do whatever we like in the source code. And then they're very surprised and those test cases start to fail for no apparent reason. Right, that's another problem. If you run your changes one after another, and then something breaks, well, that happens. What do you do about it? One option is to have a red flag and say, well, everyone, stop delivering. Now we're going to sort it out. And then you have like 200 people waiting for you. And it's actually very stressful. I know people who are doing that. It's a very stressful job. And you have to find responsible developer, making sure he's working on that, and then make sure that other people are not delivering. Or you can try to automate revert, which is, or just simply revert, unlock the pipeline, let it go. You do it either automatically or manually. I heard the story from the team in Finland. They were quite brave guys, and they said, yeah, we just automate the whole thing. And then they were running the weekly test over the weekend, and on Monday they found the integration server very busy reverting changes one after another, because basically it was IT change and all test equipment went offline, so nothing managed to accomplish. So yeah, and start to revert things one after another. Well, it was Git, it was easy to recover, but still, you have to pick your battle here. Usually, just reverting works, because then you unload developer, he can fix the problem properly without stress applied on him. But, well, if you like command and control, it also kind of works. Another way to look on this is to compare the car breakdown to the situation we have with the continuous delivery pipeline. If you break somewhere in the middle of forest, you don't stress anyone, there is no one there. And if there is someone passing, most probably they will just stop by and try to help you with the car. But if you are in the middle of the traffic jam, everyone unhappy. Everyone hate you. And that's what happens when you are part of the team of 200, 300, 400 people. And then you have to calculate how much changes you can get through the continuous delivery pipeline. That's a little slow, and definition of that I can remember, so that's why I have it written here. So the long-term average number of customers in a stable system is equal to the long-term average effective arrival rate multiplied by the average time a customer spends in the system. What does it have to do with continuous delivery anyway? So think about the customers that arrives as a commits, and then commits spend certain time in your continuous delivery pipeline. So you can use this formula to calculate how much changes you can pass through your continuous delivery pipeline without creating a queue. And you don't really want to have a queue, because if you have a queue and something breaks in continuous delivery pipeline, then you don't have ability to verify the last commits that were in a queue, meaning that you have a theoretical possibility of hidden problem. when you unlock the pipeline, right? So you don't really want your developers to wait. And then if you have the continuous delivery pipeline running for 8 hours, that basically means that you can have one commit during the workday. And then you have to work on something. You either have to reduce number of commits coming, or you have to improve your automation. It's easy as that. How do you, I think you have an idea how to improve automation, but how do you reduce number of work in progress? You start to fire developers. This is what you do. Well, no, not really. You start to think in matters of component-based software engineering, the big thing 20 years ago, and another way of people call it today, the cool kids, monoliths and microservices. It's basically about the same thing. So you want to think about your software as a set of components that you put together when you're ready to ship. So then you can have a separate pipeline, the smaller pipeline for every library. And then you will have a much less number of changes coming to every pipeline, right? And if that pipeline breaks and you have only one change a day or one change per 2 days, there is no pressure to fix it. You don't stopping anyone. And then you basically put your product from those components all together. Well, think about dynamic libraries, for instance, and then you just bring it all together to the big package. And then your continuous delivery pipeline will look more like this, right? So you have a small pipelines for every component that runs from commit to publishing, and then you will need to have something like Artifactory or Nexus, where you store your binaries, and then you have a bigger pipeline that basically responsible for assembling those changes, and also rotation of the baseline for your binary baseline. Yeah. And obviously, we are in embedded, which means that you have variants. So it's going to be more like this, depending on architecture you have. And then you can have even more higher level aggregation pipeline to get the general status of your products if you like to. Which brings us to the build systems, which are very important here. And just ignore NPM. We are in embedded world. NPM doesn't really belong there, at least now. If you're still running make, you are in trouble. If your build system is a GUI that was shipped by some vendor and your build process is clicking a button, you are in trouble. You have no way of automating that. You want your build to be run as a script, and then you want to have a build system that possesses 3 qualities. One is separation of what from how. That's very important. In make, you basically put it all together. You describe how to build the software, and you also describe what to build. You want description of how to build implemented as using some programmable language as Python or Groovy, for instance. If you are familiar with BitBake, think of BitBake classes. This is a typical separation. You can test BitBake classes, or you can use Python classes. So you can test your build system without running the build. And then you have recipes that basically using the plugin or BitBake classes to specify what to build. Second part is awareness of configurations. So you want your build system be aware of your variants and have a configuration files instead of different build recipes. In this case, you can encapsulate all your differences between variants in configuration file. Think if you are building for different processors, then you can put all related compilation flags in the configuration files, and then you basically use the same classes, the same recipes, and if you build for a different variant, you would just swap the configuration file, right? And the third biggest part is that your build system should be able to retrieve your dependency from outside, which is not present on your local disk. Think of downloading binaries from Artifactory, like Maven does for Java projects. Have you ever seen a huge Java project that's using Maven? Usually they're pretty small, because Maven is capable of downloading the other components and adding them to your build. So your actual project is just a few lines of code putting all those components together. You want to be at the same stage. So you want to have your libraries in the Artifactory and then Yocto or Gradle capable of downloading those dependencies to you during the build process so you can integrate it into compilation or linking process. Gradle is actually coming to C world now. It was a Java build system, but now they have a Gradle for native, which looks very promising. So if you haven't looked into that, I would recommend looking into this. If you're doing the embedded Linux, then Yocto is more or less the only alternative. But another thing that you can do is you can use Yocto to build the SDK and build the image, and then provide the capability in your software to download the applications on top of that, because you need to do continuous deliveries there anyway. So you need to have ability to update the parts of your software instead of updating the whole image. We can speak more about that later on. And yeah, it's all great, but where do you start? And that journey gonna be long. But the good first step is to think what manual process your developers or test engineers run a lot every day. For instance, if you don't have any continuous integration, then most probably it will be your build process, because developers have to build. That's the first step they take to verify that they're doing things right? They check that it's buildable, which means that your build script executed multiple times a day, which means that they're in a somewhat good shape just to be placed to the shell script or the PowerShell script, so you can run it from the script automatically. Then you get Jenkins, here you go, you're already doing something. If you already have continuous integration, think what is next. Is it the deployment that you're doing manually, but you do it often? Which means that here is the biggest gain you can get in the shortest amount of time. You really want to hunt for those. If you'd like to get yourself a little bit more educated, then read those books. So Continuous Delivery, amazingly boring book. This one is it's more educational, but it's more fiction, really easy to read. And if you are into embedded, large-scale agile deployment, that's the HP story, how they went from building all possible variants of printers to one and actually implemented continuous delivery pipeline for that. We hope to get one of the afters to the next conference as a keynote speakers eventually. And then continuous integration by Martin Fowler. There are a bunch of case studies done by Daniel Stoll, who will be speaking today later. And that's basically it. I'm ready for your questions.